Today's problem was submitted by a viewer, and it says, can you please make a video on this problem? And please do not use any advanced theories such as probability functions. Okay, so I'll try to interpret the level of the problem and use types of mathematics that would be appropriate for that level. The problem says, Kate and Ben are on two different trains heading to the same station. Kate's train will arrive between 3 and 4 p.m. Its arrival time is random and equally likely for any moment within that hour. Likewise, Ben's train will arrive between 3 and 4. Its arrival time is also random and equally likely for any moment within that hour. Upon arriving, both Kate and Ben will wait at the platform for 15 minutes and then disappear. What is the probability that Kate and Ben will run into each other on the platform? Okay, so I think my first intuition here is to, of course, we're thinking of the time between 3 and 4 p.m. Think of that as a unit interval. And the times at which they arrive are independent. Well, it doesn't say they're independent, but I assume they're independent, uniformly distributed on that interval. And there's we need the two arrivals to be within 15 minutes of each other, or if we translate that to length of interval, they need to be within 0.25 of each other, one quarter of the interval length. So I think the best way to figure this one out is to, I'm going to draw a square to represent the unit interval on one axis and the unit interval on the other. And based on what's given in the problem, try and figure out which points correspond to them successfully meeting. And that'll be it. Okay, so here is the interval, or the two axes. I'll just call two axes x and y. So there's 1 and there's 1. Now each of them arrives randomly, uniformly here. So basically I have a point uniform in the square which corresponds to their arrival time. So a point like this would mean, well, let's call the two axes K and B for Kate and Ben. A point like this means Kate arrived at this time, looks like around 15 minutes after the hour, and Ben arrived this time, very close to the end of the hour. And so what I want to do here is draw a picture, or draw a region in here, which corresponds to the two of them successfully meeting. We basically need the 2 points, we need the two coordinates to be within 0.25 of each other, right? So as long as K minus B in absolute value is less than or equal to 0.25, a quarter of an hour. So this means K minus B less than or equal to 0.25, or B minus K less than or equal to 0.25. Okay, so this inequality becomes K less than or equal to 0.25 plus B. And this one becomes B. Well, let's write it all in terms of K. This becomes K greater than or equal to B minus 0.25. So these are two lines. These are equations of two lines. I'm going to rewrite them again just because I'm thinking of K as being on the horizontal axis. So let me write this one as B greater than or equal to 0.25 minus K. No. K minus 0.25. And this one is B less than or equal to K plus 0.25. Okay, so, oops. Both of these lines have slope of 1. And they both intersect at sort of the 0.25 mark. Okay, so I take a random dot in the square. If it's within this region, then they will successfully meet on the platform. Otherwise, they will not. So let's look at as an example, any point that's on the 45-degree line here means they arrive at the exact same time. And of course, they do meet. But I'm just making sure that this does in fact correspond to what's given. If their arrival is within 15 minutes, that's what this says, then whoever arrives first will wait, and they're there when the second person gets there. If their arrival is greater than 15 minutes apart, the first person arrives and leaves before the second person arrives. Okay, so a point like this means Kate arrived, a point like this, that point that I drew there, Ben actually arrives first here, right? The time of arrival of Ben is a little bit more than halfway past the hour, whereas the time of arrival of Kate is later than that. If Kate arrives later, like here, then Ben will have left. Okay, so we need to figure out the area of this region. I think the easiest way to do that is to compute the area of this triangle. So this is 0.75. So that area is 0.75 squared over 2. But there are 2 of them because there's the lower triangle here and the upper triangle there. So the probability we're looking for, the probability that they meet, right? Yeah, is 0.75 squared. Well, it's 1 minus this. So 1 minus 3 over 4 squared. 1 minus 9 over 16. So what is this? 7 over 16. That's actually it's a little less than a half. What would you intuitively kind of think this would be, given that one person waits 15 minutes? You might think it's less than half, right? Because they're waiting less than half the time. But yeah. Anyway, that's the answer. I hope. I hope I didn't make any mistakes. I hope the reasoning was quite clear. I think the key here was, first of all, realizing that we can think of time as being, because it's only between 3 and 4, it's nice to think of it as just being uniform on a one-dimensional interval. And then, of course, the set of all possible combinations of times they can get is going to be uniform in the square. And then just figuring out, based on the wording of the problem, given how long they're going to wait and disappear and all that, translating that into the set of successful points. Doing that was made easier by translating the statement into a mathematical inequality. So this was a nice little problem. I'm curious where it came from. Maybe it's like some kind of contest or something like that. But hope you enjoyed. Thanks for watching.